Welcome to another video. We are going to discuss prismatic machining in CATIA V5. This will be the case study part. If you only want to see the aspects regarding prismatic machining, you can skip at the bottom within the video section directly to that. So I intend to make this video easy to follow for everybody. That means that I will also create the part. So that will be the first step. Therefore, I will start a new part within part design, select the X and Y plane, and I will use the center rectangle to define a new sketch. And let's see, the vertical will be 100 and 150 for the horizontal. Now I will have this padded 20 millimeters in order to reach this part. Now on the top part I will define a new sketch, and over here I will create two circles. So the radius will be 4, the diameter will be 8. I will create one at the bottom as well. Okay, diameter of 8. This is radius 8, so we want diameter to be 8. Okay, now I will center these two circles at a distance of 50 millimeters from the edge of the part. I will do the same on the bottom side, so redo the constraint, add the value, the same value from the point up to the bottom edge. Now I will use the mirror in order to copy this on the other side. So I will do a rectangle selection, mirror, and mirror those along the vertical axis. And I will pad them, so pocket them, sorry, on a distance of 20 millimeters. So this will be the end result. Now in order to add other design features, I will create a new sketch on the top plane. And over here, using the center rectangle, I will define two rectangles. And now let's add in the dimension. So over here, for the first one, which is horizontal, I'm gonna add 100 length, and this will be the other axis. So where we have 39 on the screen, I will add 30. And for the other one, I will make it 70 by 50 over here. So this will be the profile. Now using the erase, I'm gonna trim everything in the interior so that we can add a radius over here that we can later machine. Okay, and now I'd like to add a radius of 10 to everything, or I can make the radius different. So let's see, I will select the middle 4 points and I will make them to have a radius of 8. So with those points selected, afterwards I can go on the corner, and now I can visually drag the amount of fillet. I can press tab, that will take me at the top on sketch tools, and I will type in 8. So for that interior I will make it 8, and for the other points, as you can see, the other points will be 8, 4 on each side. I will add a radius of 10. So using the same workflow, with control click you can select multiple, add that radius of 10, and this will be the profile that we are gonna have cut on a distance of 10 millimeters. Now I would like also to create an offset border for the part, therefore I will create a new sketch. Within the newly defined sketch, I will select the 4 edges and have them projected using the projection feature. And afterwards, with the same selection already selected, I will create an offset of 5 millimeters. So this will be the newly defined sketch. I can also come over here and add those values. So the lines will no longer be white, they will be green, that means that the software knows exactly where they are. And also we have that visually because the value of so the position didn't change during this operation. Now with this sketch, if you want to, we can make it a little bit lower. Now I will let it like this with 5, and I will just adjust the chamfer so that those won't be, let's say the final chamfer won't be too close to those sections. Exit the sketch and have this pocketed on a distance of 10. And now I'll also add those chamfer values. So using a length of 10 on all 4 edges, our profile will look like this. So we're gonna have enough, let's say, relief over here, not to be too close to that cutout. And I will also add some additional geometry over here. I will select the top plane, so the top surface of the part. I will define a rectangle over here. And this newly defined rectangle, I want to make it symmetrical to the horizontal axis. Therefore, I will select those 2 edges, the axis, and we're gonna have over here the symmetry value. I'm gonna add a value over here 37, another value over here 15, and I will make this edge coincident to the other edge. Now I also want this on the other side, therefore I will make use of mirror. And I will also add some radius over here that we are gonna later machine. So I will select those 4 corners, go to radius, and I will add a radius of 10. So this will be the final shape, and we also wanna have the material removed over here. So pocket on 10 millimeters. This will be the design part. So just like within the last video for surface design, I will go over here on part body, have this name design part, and define a new body, which I will rename to stock. And within this newly part body, I see that this is the active one since we have it underlined. I'm gonna go on the bottom side and I will project the contour. It's really important that I select only those 4 edges. If, for example, I will just select this, afterwards project, since we have those cutouts, that will be also projected. So this is not, let's say, useful in this case. So I will just select the 4 edges because we want our stock to have, let's say, fill material. This will give us that prismatic shape. I will have this padded on 20 millimeters, not mirror extend, but reverse direction because we want it to overlap our part. And I will also make this yellow and transparent so we can better see the part over there. Now in prismatic roughening we can also define some planes. Therefore I will use an offset plane from the top, 20 more millimeters. So this will be a safety plane when the machine will retract. So this will act as a safety plane over there. Okay, so this is, let's say, the part. I will also add another cut over here in the middle. So I forgot about that. Therefore I will go over here to design part, right click, defining work object, hide the stock, and I will make another circle in the middle, let's say diameter 30, and I will cut the material up to the bottom of the part. So I could go up to next, that will do the same. So this is the part, this will be the stock. If I'm gonna hide the part, we're gonna see the stock. Therefore we can go to prismatic machining. So I will first save the part, call this prismatic. Afterwards start machining we're gonna see prismatic machining over here. Now we need to define the machine, so double click on part operation. For this, again, click on the machine, and it will be a 3-axis machine, just like within the last video for surface machining. Now we just need to fill in the design part, which will be this one. Double click on part design. The stock will be that stock. And since we have that plane defined, I will make use of that safety plane over there. Afterwards, click on OK. We can hide the stock and we can take a look at our design part. Now, in order to do the machining for this, initially I will define some spot drilling in order to mark these pockets, so those 4 pockets. I'm gonna start with those. Therefore, I will select the manufacturing program, and over here we're gonna choose spot drilling. And for spot drilling, we need to select over here initially this area, and afterwards the circles. Now, regarding on the selection method, we're gonna see that pattern. So we see 1, 2, 3, and afterwards 4. And we can also have that rearrange if we want to. I will leave like this: 1, 2, 3, and 4. Afterwards, double click over here, somewhere on the background. And now we need to define the tool for the spot drilling. In this case, we're gonna see over here at tools that we can choose a spot drilling. We know that the diameter is 8 millimeters over there, so I will make use of a spot drill with a diameter of 4. I'm just gonna change over here the nominal diameter to be 4. And afterwards, we also need to add the depth. So in this case, I want the depth to be 2 millimeters for this spot drilling. I'm not gonna go over here and adjust those. I'm just gonna leave them to automatic. Let's see the total time. So for this, with the automatic, we're gonna see the total time will be very low, so 1.7 seconds. And if you're gonna start the simulation, we're gonna see that this will be the spot drilling. So all those will be marked. Okay, since we have that spot drilling enabled, we can go and proceed. I'm gonna choose the drilling deep hole. For this part, consider that the part would be positioned on the machine, let's say bed, but also we're gonna have a little bit of offset, so we can go with the drilling all the way to the bottom. So we can have this position over here in some areas and have it clamped over there, in order to enable us to do this drilling deep hole to pass through the whole part. So for drilling deep hole, I'm gonna select that profile, and again we're gonna choose the 4 circles at the top. Afterwards, double click. We're gonna go for the tool. This will no longer be a spot drill tool, so we're gonna make use of a drill. I'm gonna change the diameter to be 8 over here as well. And by default, if I'm gonna let it like this with 20, that's the depth of our part as well. If I'm gonna go to simulation, we see that the time was 5 hours, so we have to adjust those let's say machining times, because we're gonna have this plunge up and down for each hole if not, so we need to increase those machining speeds. But we see visually that now the drill will not pass to the other side, therefore we need to adjust the depth hole. So I will go with more, like 24 in this case. We see that the drill has this hole, so we cannot adjust the end. We can only adjust the diameter. But like this, we're gonna see that we're gonna have that pass through. Now, regarding that processing time, this is set to automatic, so keep in mind that this plunge speed is currently set only to 10 millimeters per minute, and that's why it takes so much time. You can adjust the feed rate and the spindle rate, and that will increase. But this is again highly dependent on the machine that you will use to process this. Since this is just a video where I discuss various aspects regarding this, I'm not gonna go within specific values for machining on a specific equipment. So we have that defined, the spot drilling, the drilling deep hole. We can now go and remove those with a prismatic roughening. So you can find that over here, prismatic roughening. And we're gonna have offset on part. If I will set this to 0, this will also act as, let's say, the roughening directly within the same operation. Not like we did within the previous video where we also had some finishing operations. So if you only want to do something like this visually, we can choose that directly over here. So for the part, the design part will be from the part 1. The stock will be selected as well. And let's see, we have the possibility over here to do only the pockets only. Pockets only are considered to be the areas within the part. So in this case, this section and over the one at the bottom. I'm gonna leave the default values over here. This default value will also have a ball end, and we're gonna see what will be that problem. Also, this has a diameter of 10, but we have in some areas a radius of 8, but that shouldn't be any problem. We see that the offset on horizontal area must not be greater than the offset on part. So we have the offset on part set currently to 0, and we have this offset. I'm gonna add that to be 0 as well, so we won't have that warning anymore. Keep that in mind if you will see that. Now if I will go and do that simulation, we're gonna see how our part will look like. And we see, since this is a ball end, we're gonna have a lot of scallop remaining over here. So to address that problem, we're gonna need to change the tool. That means I'm gonna uncheck the ball end. Therefore I will make the radius to be 0. I will also make the diameter only of 8 for this. And other values that we can change. I'm gonna change the machining tolerance again to 0.01, just like within the last video for surface machining. For the radial step over, I will choose to go with step over length and have this set to 3. And the same for the maximum depth, again only to 3 millimeters. So this will increase the machining time, but we should obtain a better surface. We see the computational, we see the total time with those automatic feed rates. If I will go directly to photo, I can directly see how this will look like. And we're gonna see that nominal values. If I'm gonna go and click on various area, the nominal deviation will be 0.01. So that is quite a good deviation. We see that this has turned yellow for everything in the middle. But we are within, let's say, the intended machine tolerance with these settings. That shouldn't be any problem. And we can do the same operation over here if we would use the same tool. Within the prismatic machining, I can do also the outer parts and pockets. And the same tool should be able to do this with no problem, because we have large radius over there. So let's take a look at this. If I'm gonna play the simulation. Okay, so let me redo that. I'm gonna start the simulation. And we're gonna see those. So this is the pocket, and this will be the outer area. And we're gonna see how those will be machined. So considering that we made use of large radius within the case study part, we can do those with this tool without any problems. Okay, so I hope you find this video useful. I will also put a similar link, a video to the left of the screen and a subscribe button to the right. So thanks for watching, see you in the next video.